we're going to talk about this, which who's actually read this paper, start to finish? Okay, great. So in July last year, Uber published a technical paper describing why they were moving from Postgres to MySQL. And of course, the Postgres community's reaction to it was something like this. We were, of course, very moderate and reserved in our response. Actually, it was a pretty good paper, and it was worthy of some actual analysis, so we're going to do that. So to summarize the complaints, we're going to divide them into kind of sections. There's write amplification, replication. There was a bug in 9.2, replica MVCC, that's what they called it at least, upgrading, buffers, and connections. And so we're going to go through each of those thing by thing. So there was a lot of speculation about what the real motives of their switch was, and we're not going to talk about that. We're going to take the paper as the entire universe of discourse here, and we're going to take them everyone at their word because of what they experienced, what they said they experienced, because at the point you start speculating on that way madness lies. So who's familiar with how Postgres does MVCC? Okay, for the rest of you, that's too bad because I'm not going to take the time to explain it here, but it's because a lot of their complaints center around the different ways that MySQL versus Postgres does multi-version concurrency control. So the first complaint was write amplification. So here was the complaint. Postgres's index implementation points directly to the tuples on the disk. So it's a one-level structure. You go down the index, you hop from the index straight to the on-disk structure, which means that if you change a tuple, you have to create a new version, which means you have to update all the indexes that pointed at the old version to point to the new version. This means if you have 12 indexes, that you're updating 12 index entries on top of the one tuple you updated. So this is, and the problem is this amplifies writes. So you're doing a bunch of writes, and all these tuples are changing all over the place. And MySQL is better for this reason because it uses a two-level index for non-primary keys. The key value points to the primary key value, which points to the row. So updating a row only writes that one row. And you only need to rewrite indexes on primary key changes, and how often do you change primary keys? Not very. So we're going to call that one half true and half false. It is true that you have to update index if a change to row updates any index. That is absolutely a true statement in Postgres. That is not, I would call, a feature of Postgres, and there's ongoing work right now to fix that. That may or may not make it into version 10. And Postgres keeps each version of the tuple on disk until it's vacuumed. This is absolutely true. And anytime you change any of these things, it has to push them down the binary replication link if you're using binary replication. So yes, you could have this one tuple change turn into a bunch of page changes. Absolutely true statement. But if the column that is being changed isn't indexed, you generally don't have to change any index pages. There's an optimization Postgres called HOT that's been around for a long time that prevents that. There was this statement that the Postgres auto vacuum process has to do full scalable to deleted rows, which was true in 1998. It has not been true for over a decade, so I'm not sure why they made that claim. There were a couple missing observations here also. The MySQL MVCC design requires a rollback area. It is optimized around the idea that there's kind of this primary version of the database that's moving forward and a bunch of people are reading at it, which is not, and Postgres is that there can be multiple versions at the same time, and they're all peers with equal access characteristics. And this does hurt concurrency because you have to reconstruct the old state of the database if you've changed a bunch of stuff. And if you look up anything on a non-primary key index, you're doing 2 index lookups, not 1. And walking a large B tree is not fun. Okay, their next complaint was about replication. So Postgres approaches every single page change down the binary replication link. This means indexes, changes, all that stuff is included in the stream, which can create very large bandwidth requirements, especially if you're pushing over a WAN link. MySQL is better because it only sends down logical changes, like the insert statement or the update statement that it did. So the index changes don't have to be pushed down. Those are reconstructed at the secondary, which is a lot more compact. The problem is this is comparing apples and oranges. It is true that Postgres doesn't have logical replication in core. It's coming in 9.10, or in version 10. However, and it is also true that logical replication tools, which are not in core, like Sloaney and Bucardo, are somewhat fiddly to set up and manage. That's no one's idea of a good time. You don't go to work in the morning and say, great, I get to set up Sloaney. But come on, this is Uber. They don't have the engineering resources to deploy something that I do in an afternoon. And the biggest problem here is this compares MySQL logical replication to Postgres' binary replication, which is not an accurate comparison. And Postgres has had logical replication since ever, so you can't say we're comparing this because Postgres doesn't have logical replication. And 9.4 and higher has had logical replication as a plugin you can just drop in. So you don't even have to mess with Bucardo or Sloaney. Okay, next complaint was about database corruption. 9.2 had a database corruption bug around streaming replication, which it did. Early versions of 9.2. And it was really unpleasant. So they said, to summarize, but to paraphrase, but I think accurately, Postgres has a bug, so we're switching to MySQL. Okay, if that's what you want to do. So those bugs were very promptly fixed by the Postgres project. I have used MySQL. I would not call MySQL bug-free, and we'll just leave it at that. The next comment was replica MVCC. The statement is Postgres does not have true replica MVCC support, which is kind of a little bit of an argle-bargle statement, I have to say. This is not the way I'd put it. So the complaint is incoming changes to the replication stream can either delay replication or cancel queries. Who's experienced this query cancellation message from Postgres? If you haven't, you will if you use Postgres. And MySQL is better because it only sends down logical changes. They're transactional like any SQL changes, and the queries are not blocked by incoming changes. And this is, once again, an apples and oranges comparison because it's comparing streaming replication with binary replication with logical replication. It is true that incoming streaming replication activity can be blocked by queries or the queries can be canceled. And this is annoying. And it's very surprising the first time this happens. But it's configurable. The general setup is that you have a close replica for failover and a delayed replica for queries. So you get around this. And again, we're comparing two very different technologies, binary replication, logical replication. And this was a problem for Uber because they had a lot of long-running transactions because, and to quote verbatim from the paper, well, it's always bad form to let your code hold open database transactions while performing unrelated blocky I/O. The reality is that most engineers are not database experts and may not always understand the problem, especially when using an ORM that obscures low-level details like open transactions. Okay, your code has bugs and MySQL deals with the bugs better. Great. Low-level, incoming SQL-level operations will take locks. Updates and inserts take locks, updates take locks just like anything takes locks. And long-running transactions can block other sessions by holding these locks. And it's not clear if this is better or worse. And the paper doesn't go into details on why this is better or worse. Next complaint was about upgrades. Postgres upgrades can require a lot of downtime, which is made worse if you have a large fleet of secondaries running off a single primary. And pgdump and pgrestore style upgrades aren't practical for large databases. So this is the simplest way to upgrade a Postgres database. But if you have a 3 terabyte database, this isn't happening. And you can use logical, but MySQL is better because you can use logical replication to upgrade from one machine, replicate to it, then fail over, and the switch over is really fast. Sounds like a great idea. Why doesn't Postgres do this? I mean, morons, geez. It is true that we don't have in place major version upgrade. You can't just take down Postgres, bring it back up on the same data file with a major version, expect it to work, because it won't. You have to do some kind of process to get low downtime upgrades, and this does require some planning and tooling and general unpleasantness. PG Upgrade, which is a tool that can do in-place binary upgrades, is a big improvement, but it's not a panacea, and it is pretty fiddly. Especially if you're using PostGIS, which a lot of people are, PG Upgrade can be really annoying. But again, Postgres has logical replication forever, and we've done all sorts of upgrades. Exactly the same process. So I'm not exactly sure why the distinction here. And again, this is a company this is not one guy in a garage. This is a company with an engineering staff. You can figure out Sloaney. So the next complaint was about buffer pools. Splash. The complaint is Postgres' buffering system relies heavily on the file system cache, which it does. It even says so in the documentation. And pulling systems to file system cache while it's faster than from disk requires a context switch to the OS. So if you pull it from shared memory, you just copy it, but you have to context switch, do the fcopy, do the fread, come back, and all that, and that does require a context switch, and this is bad. MySQL is better, it is claimed, because it relies more on its local cache. So it has more local cache to pull from. So it can read more data without having to do these context switches. And this is just the best thing ever. And, okay, mostly true. Postgres' shared buffer management performance peaks at between 8 and 32 gigabytes. We think. I will say generating the data on this has proven, every time I do data, it's actually like a flat line across. So I'm not exactly sure how much shared buffers even matters. But shared buffers larger than this range results in diminishing returns because of the way Postgres manages the algorithm it uses to manage its shared buffers. And unquestionably, retrieving things from the file system cache is slower than from shared buffers. But I don't know what difference this really makes. And Uber didn't say if they do. General OLTP systems are not super sensitive to shared buffers. It is hard to generate much data that demonstrates that having 8 versus 32 versus 64 gigabytes of shared difference makes a huge difference, which, if this is a big problem, you would think it would. Unquestionably, it improves performance, but by how much? I don't know. Connection management. Postgres forks a new process for each new connection. And this results in high latency and RAM usage for each new connection. And it's hard to scale a Postgres above a few hundred connections. And MySQL is better because it uses threads instead of processes. And each connection is much lighter weight, so it allows us to scale many more connections. This is mostly true. The forking model is not efficient for a lot of connections or for connection cycling. While you can be misled by just looking at top and things like that, each backend, each connection management process in Postgres does require a significant amount of memory. But the problem is this conflates two things, which is connection establishment with connection activity. Postgres can handle a lot of busy connections at the same time, even if firing up an individual connection is expensive. Generally, and there's nothing in the paper that contradicts this, number of hot connections, things that are actually running queries in Postgres and MySQL are equivalent. And there's presumably some context switching involved here, but again, it's not been demonstrated what the real life impact of this is. I'm sure it's non-zero, but I would like to see a benchmark that actually shows it. And we've had a tool for years, thank you to Skype, for mitigating this problem called PG Bouncer, which I hope everyone knows about. It's not always a drop-in replacement, I'll admit, and Uber even tried to use it. They mentioned it in the paper. However, we have occasional application bugs in our backend services that cause them to open more active connections, usually idle and transaction connections, than the services ought to be using, and these bugs have caused extended downtimes for us. Okay, fix your app. To conclude, first, MySQL is a fine database. I am not here to trash MySQL. It is a fine database. It does a lot of stuff very well. So if you came here for the snark, here's the snark. MySQL people are easy to find. As a pure blob store with little concurrent activity, it's really fast. It's great for WordPress. And that insert null primary key thing totally rocks. Okay. To be fair, Uber did identify some real problems. I mean, they were not just hallucinating these issues. A lot of them are issues with Postgres, and the project acknowledges them. They're subject to active work. For example, the rate amplification thing caused by indexes is actually, there's 2 different patches that are competing for attention right now on to mitigate that. And it is unquestionable they were experiencing some real headaches. I mean, they didn't just dream that. But they consistently conflated a problem with binary replication with an advantage of logical replication, and as if binary and logical replication were binary was specific to Postgres and logical was specific to MySQL, which has never really been true. And slow debug are fiddly, but I'm sure Uber can make them go. If I can make it go, anybody can. Also, we've had PG logical for a long time now, which solves the problem in core very efficiently. And one of the things that did bother me about the paper is a lot of these things were performance issues with zero quantitative information about how bad the performance issue really was, which is hard. It is hard to evaluate a claim on that basis. They also do note that they had already made the decision to move to a schemaless architecture. So maybe having an engine like Postgres was no longer a big benefit to them. And I'm not sure how to react to the MySQL handles our devs bugs better, as a point. Okay, noted. And that's the talk. Questions? Yes, sir.
So I've experienced some things with Postgres buffer pools before, shared memory. It can take a really long time to write out 30 pages. Is there any active work on the backward writer happening that you know of?
Well, it depends on how it's set up. It is possible on a database that is very, very write intensive to shared buffers too high. In which case the answer is turn down shared buffers. And it actually, because shared buffers are not a huge benefit for a write intensive database because, it's a write through cache at that point, and why make it any bigger than it needs to be? What generally you need to do is either bump up checkpoint completion target, bump up checkpoint timeout, and turn down shared buffers so that when it hits one of these checkpoints, the whole system doesn't start choking as it tries to shove 8 gigabytes down the wire at the same time. You do have to tune it a little bit, and that's not no who likes tuning? I don't, but so yes. I ran over last time I gave this talk. Yeah. Okay. What specific feature? Name a feature MySQL logical replication has that these lack. Mm-hmm. Right. So you use execute script instead of just doing the DDL change. Okay, I would hope any engineer who knows who's old enough to drink was able to be told. So this is all automated, right? No one sits out their console and types in create table anymore, right? It's not a limitation; it's a difference, right? Well, the point is, it is one thing to say DDL cannot be replicated. That statement is false. It is true that it does not automatically pick up DDL changes and push them down, which PG Logical does. So use PG Logical instead. It's been around since 9.4. That's, 3 years now? Well, okay, but to say Postgres if it had been phrased as we will now demonstrate the core features of Postgres versus the core features of MySQL, that's one thing. But that's not what the paper was. It was how in our enterprise this tool works versus that tool works. But nobody uses exactly and 100% the core features of anything, right? At the point you sign up for a configuration management tool, you've already admitted that the core the core isn't sufficient. So if that was their intent, that's an interesting paper, but that's not the way the paper was framed at all. Well, I'm not a member of the team. I'm not a member of the core team, so I'm not going to specifically. I'm not going to be the core team's press agent here. So I'm not exactly sure what your question is. Is the question, are these being worked on, or how would they be how would you know? So the answer is, how would you know, is sign up for the lists. Which frankly, to sort of head off a possible objection, if people are really going to slog through a bug tracker looking for, playing with the query strings until they think they've gotten their issue right, asking on the list is probably a more efficient way of doing that. Yeah. They would be unique among large startup engineering organizations if they behave that way. Let's say that of all the many things that I could criticize them for, not doing that is not one of them. There is a great deal to be said about large well-funded companies, their use of open source software versus giving back to the community. But I'm being hostile enough, so that's a different rant. So, but I agree. It would have been interesting for them to go on the list and say, "Hey, these are real problems. What's the solution?" Because then I wouldn't even be giving this talk, because then I'd have an answer to the "Why didn't Sloaney work out for you?" question. I mean, again, most of these decisions are not driven by technology. And that's fair. And I don't mean that. I mean that in a completely open-hearted way. You acquire a company that has 500 MySQL familiar engineers. You're going to that's going to push you very strongly in a particular direction just for pure economics, and that's reasonable. There's absolutely nothing wrong with that. This paper, however, was framed as a technical discussion. Therefore, that's why I'm confining myself to the technical points. Yep. Great. Thank you very much.